that entire time. All right, so let's recap. We've talked about exponential functions where the base is the number, the exponent is the variable. You know it's exponential growth when b is greater than 1, or when the number raised to the exponent is between 0 and 1, then it's exponential decay. All exponential functions have a what? An asymptote. This is a line that the graph comes exceedingly close to but never touches. All right, let's talk about domain. Look at this exponential function. What do you think the domain will be here? What is the domain? Is there an x value when I scan this horizontally where there doesn't seem to be a graph? Right? Is there a graph here? Here, 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 here. There's a graph everywhere, so the domain is going to be all real numbers. Okay? Well, what about the range? Where does this start? It starts at 0 and goes up forever, right? So the range here is y is greater than what? Y is greater than 0. Now, can it be y is greater than or equal to 0? No, because it never hits 0. All right, let's graph one of these. Yes? That's why it's greater than. It comes very, very close to 0. So it goes all the way down to like 0.000000001, right? So it's greater than 0. Okay, let's graph one. So to graph, no. Well, yeah, well, we're going to do millions of application problems. You'll see where we're using them. Okay, so we're going to graph this. Before you graph any of these functions, what you need to do is identify whether it's growth or decay, right? So in this case, is this growth or decay? It's growth. How do you know? Because of this 2. The number raised to the exponent is greater than 1, so this is growth. It's 2 to the x, right? The number that has the exponent is 2. Since that number is greater than 1, it's growth. All right, so the asymptote, the default asymptote is always going to be y equals 0. And we'll talk later about when it's not going to be y equals 0. All right, so for now, the asymptote is always y equals 0. Okay, the y-intercept, right? What point is this? At the y-intercept, what's the x value always? 0, right? The y-intercept is when a graph touches the y-axis, and x is 0 at that point. So y-intercept is when x is 0. So what we do is we say y is equal to 2 to the 0 to get the asymptote. And how much is that? 1. So the y-intercept is 0, 1. Okay, the y-intercept is when x equals 0. The asymptote is y equals 0. That's the default. I haven't told you yet when it's not going to be y equals 0. All right, now, we said that this was growth, right? So, to pick points, when it's an example of growth, I always like to pick these values, -1, 0, 1, and 2. Now, you can pick any values for x that you like. I myself, this is just a preference that I pick these. And the reason why I pick these is because these give me the relatively manageable numbers to work with, okay? So -1, 0, 1, 2. All right, so let's plug all these in here. First off, I have 2 to the -1, right? And now that we've done our chapter 6, we know exactly what that is, right? This is 1 over 2, so this is a half, okay? Next, I have 2 to the 0. How much is that? 1. And I have 2 to the 1, and that's 2. 2 to the 2, that's 4. Anything to the power of 0 is 1. Okay? Now, let's first graph the asymptote. It's at y equals 0, right there. All right, I'm putting it right on the line on the test. You can put it like right above the line so it's visible, right? Okay, now, when... And the asymptote is a line that the graph will come close to but never touch. We got that the asymptote is y equals 0. Y equals 0 is here. It's really the x-axis. Right? This is where y equals 0. Okay. So when x equals -1, y is a half. When x equals 0, y equals 1. 1 and 2, 2 and 4. Okay, now, here we go. We're gonna graph this. So it's gonna follow the asymptote on the right, on the left-hand side, come up, and go up exponentially. All right, and this is how they all look. What I will be looking for on your graphs is A, that you've shown me explicitly where the asymptote is. B, we're not playing connect the dots. So your graph shouldn't go from the first dot to the last dot and just stop there. I want to be able to see that here it goes up forever, and here you have to follow the asymptote for quite a bit to give me the idea that this is for all eternity going to follow the asymptote. Okay, what's the domain? All real numbers. All right, so I'll give you a little secret. You ready? Don't tell anybody. Not even your moms. Not even your dads. You ready? The domain for all exponential functions is always all real numbers. You don't even have to think about it. Don't tell anybody, but you don't even have to think about it. Every single time, this is your free points right here. Okay, the range. Y is greater than 0. Can I say y is greater than or equal to? No. Will it be wrong if you do? Yes. Okay? Yes. But is 1 the starting point? Because here it's at a half. And here it's below a half. And here it's below that and below that and below that and below that. Greater than the asymptote, always. Or less than the asymptote. Not always. In these cases, the default is 0. We're going to see now how that might change. Yes. So the range is always going to be either y is greater than or less than the asymptote. It's always going to be connected to the asymptote. Okay, let's do a couple of examples and you will see the pattern. All right, so transformations. Transformations run in exactly the same way. Do you remember when we had the absolute value equations? It was y equals a, x minus h, plus k. What did the h do? It moved it horizontally or vertically? Does the h move it horizontally or vertically? Horizontally. And what did the k do? It moved it vertically. And what did the a do? So the a, right? If the a was negative, what did we have? A reflection. So it's the same exact thing here. H is the horizontal translation. K gives us the vertical translation. Okay, if a is negative, it's a reflection around the what? X-axis. All right, so let's see how this is going to affect these. All right, now here I have 2 to the x minus 2. What does that minus 2 do? Where does it move the graph? Up, down, right, left? Down, right? It will move it right, left if it's next to the x, but now this is outside of the x. Yeah. So if it's like this, it'll move it horizontally. Okay. So this is going to move the graph down. It'll move everything down, including the asymptote. So if everything moves down 2 spaces, where is the asymptote now? At y equals -2. Okay? Everything moves down. The y-intercept was at what point? X equals what? 0. So let's plug that in. 2 to the 0 minus 2. This is 1 minus 2, which is -1. So it's at 0 comma minus 1. Yeah. So y-intercept is always when x equals 0, right? Y-intercept, when the graph crosses the y-axis, what's the value of x there? Here. When the graph crosses the y-axis, what's x? Okay, so what's y-intercept? This point here is y-intercept, right? That this point here is y-intercept. Y-intercept is where the graph crosses the y-axis, right? Okay, so at that point that I've circled in blue, y is some number. What's the x value? What's x? X is 0. So at the y-intercept, x is always 0. Right? Remember chapter 1 and 2 when we were looking for x and y-intercept? Okay. So here, is this growth or decay? Growth or decay? Growth, why? Because 2 is greater than 1, right? All right, so we pick -1 to 2. Now let's plug these numbers in here. 2 to the -1 minus 2. Okay, what's 2 to the -1? 1/2 minus 2. So half minus 2 would be how many? -1.5, right? So -3/2. If you need help doing common denominators, come see me at bonus. We'll work together. Okay, so here I have 2 to the 0 minus 2. How much would that be? 1 minus 2, -1. 2 to the 1 minus 2, anybody? -1 or 0? 0. 2 to the 2 minus 2? Right, 4 minus 2 is 2. All right, so let's see. I'm first going to put in my asymptote. It's at y equals -2 this time, right there. Okay. At -1, it's at -1.5 here. At 0, we're at -1. At 1, we're at 0. And at 2, we're at 2. Okay, we got to follow the asymptote, come over, and we'll go up exponentially. Okay? What's the domain? All real numbers. What's the range? Y is greater than -2. So it's always going to be tied to the asymptote, right? It's always going to be greater than the asymptote or less than the asymptote. Look at this next one, right? It's 2 to the power of x minus 1. Is this growth or decay? Growth. Huh? Which one? Okay. Tell me. What does that -1 do? Does it move it up, down, right, left? Okay, who says that -1 moves it up or down? Who says it moves it right or left? So would it move it to the right or to the left? Okay, it would move it. All right, so if you had something like this, y equals x minus 1 squared, right? Where would that move the graph? To the right. Well, here it's the same exact situation. It's x minus 1. When the number is with the x, up in the exponent with the x, it moves it horizontally, and you got to go against the sign. So this is, it moves it to the right. Okay, that means, what about the asymptote? Has the asymptote moved at all vertically? No. So where is the asymptote? 0. Y equals 0. Yeah.
It says that if it's negative,
well, it's minus h, right? It's x minus h. So what you do is you take x minus 1, you set it equal to 0, and x equals 1. So it's always the opposite sign. Okay, so what about the y-intercept? What do we plug in? 2 to the what? What do we plug in for x? 0 minus 1. So this is 2 to the minus 1, which is what? 1/2. So the it's 0 and 1/2. All right, that's the y-intercept. Okay, let's start plugging these numbers in. So we're going to have 2 to the negative 1 minus 1, 2 to the 0 minus 1, 2 to the 1 minus 1, 2 to the 2 minus 1. All right, so I'm going to give you guys 2 minutes to complete this table, put the points on the graph, and graph this function. All right, and I'll stop this for 2 minutes and we'll come back. 1/4, 1/2, 1 and 2. At negative 1, it's 1/4. And then 1/2, and then 1, and then 2. Now, I'm not looking for NASA precision with the 1/4 and the 1/2. Just that, you know, the 1/4 is somewhere lower than the 1/2, obviously. And here. And then we do this. All right. So, look, I know I've done this way more than you have, right? However, the lines, these graphs should always be smooth. If this was a roller coaster and you were sitting on this roller coaster, there should not be any bumps along the way. So if your graph has bumps along the way, then it's not a correct exponential graph, all right? There should be no sharp turns, no edges, no bumps, just a smooth ride all the way. What's the domain?
All real numbers.
All real numbers, and the range is y is greater than 0. Okay, so all this for exponential growth. So just know that when something is growing, right, are the numbers moving to 0 or away from 0? When something is growing, is it moving to 0 or away from 0? It's moving away from 0, all right? So that's important. So here, growth, numbers, meaning the y, move away from 0. All right. When something is decaying, when something is doing the opposite of growth, are the numbers moving away from 0 or towards 0? They're moving towards 0, right? So exponential decay is when numbers in the y-axis, in the y values, move towards 0. Okay, like here, like the number of bacteria gets closer and closer and closer to 0, all right? The domain is, again, all real numbers. What's the range here? If the asymptote is at y equals 0, what's the range for this graph? Y is what? Greater than 0 or less than 0? Greater than 0. It's still above. So whether it's growth or decay, right, it doesn't mean that, like, you can't say that if it's growth, it has to be greater than 0. If it's decay, it has to be less than 0. No, and we'll see examples of where that could vary as well. All right, the next one, we'll see some examples. This example, is this one of growth or decay? Decay, because it's 1 over 5 to the x, and 1 over 5 is less than 1. Okay, so what's the asymptote? It's y equals 0. For the y-intercept, now we do 1 over 5 to the power of 0. And anything to the power of 0 is what? 1. Table to the power of 0 is 1, right? Chair to the power of 0 is 1. So this is 0, 1. So let me just put the asymptote here because I'm getting kind of excited here. All right? Now, when it's decay, rather than choosing -1 to 2, I like to choose -2 to 1. Again, this is just a matter of preference. Over the years, I've seen that these numbers just give you more manageable values for y. Is it set in stone? No. All right? So 1 over 5 to the power of -2 will be what? What do we do because there is a negative exponent? You flip. So it's 5 squared, which is 25. All right, 1 over 5 to the power of -1 is what to the power of 1? 5 to the 1, which is just 5. 1 over 5 to the 0, we just said was 1. And 1 over 5 to the 1 is just 1 over 5. Does that make sense? Well, it's math. It's got to make sense. Okay? So now, I'm going to start graphing from the bottom. Okay, I'm going to be a rebel. I'm going to start graphing from the bottom. When x is 1, y is 1/5. That's like right there. Again, I don't need NASA precision. Just that it's close to the x-axis. When x is 0, y is 1. When x is -1, y is 5. When x is -2, y is 25. Now, I'm not going to graph the 25. It's okay to leave that out. All right? Just know that at -2, it was going to be all the way up there. So this is going to come up very, very like close to that 2, right? So it's going to come up very, very fast. And it's going to look like this. Asymptote here. There. Do you see that? Now, what is the domain? All real numbers. What is the range? Y is greater than 0. Okay, now, let's do one more. Huh? After the last 2. I got one more. I promise you, Maya, we're getting there. Yes. The range? Okay, so, all right, here we go. What does the positive 2 do? Move it where? Up 2. Okay? If it moves it up 2, does the asymptote also move up 2? Yes, it does. So what would the new asymptote be then? Y equals 2. What does the -1 do? Move it to the right. When it's horizontal, it goes against the sign. What does that negative do in front of the 4? It's a reflection around the x-axis, so it's going to be a reflection like this. Now, is this an example of growth or decay? Okay, where is the exponent? The exponent is here. What is the number that is being directly raised to the exponent? It's a half, and it's half greater than 1 or less than 1? It's less than 1, so this is decay. Okay? I'm running out of colors here.
What is the
-1 moves it to the right. The whole graph. We're not going to be worried too much about that right now. Okay, now, so this is a decay. A decay looks like this. So Maya, here we go. A decay looks like this, yes? Now this is the reflection of a decay, right? So if it's reflected around the x-axis, what should it look like? It should look like this. Okay, so that's what I suspect my graph will look like the red one. All right? Yes. The 4, yeah, it makes it sharper, steeper. Okay? The negative, the green. Here. All right, now, so I copied and pasted and I put the wrong equation in here. It should really have been -4, 1/2, x minus 1 plus 2. All right, so let's start plugging some numbers in here. So this is -4, 1/2 to the power of -2 minus 1 plus 2, right? How much will that be? We'll take care of that later. So this will be -4. I'm going to go down here. -4, 1/2 to the power of -3 plus 2. So this is -4 times 2 to the 3, which is 8, plus 2. How much is that? -32 plus 2. This is -30. If you want to use your calculator on these, it's fine. Okay. So -4, 1/2. Now we're plugging in -1. -1 minus 1 plus 2. So let's go on my scratch paper. -4 to the power of 1/2 times -2 plus 2. This is negative 4 times 2 squared plus 2. So how much will that be? Negative 4 times 4, negative 14. All right, let's do one more. Negative 4 times 1/2, 0 minus 1 plus 2. So this is negative 4 times 1/2 to the minus 1 plus 2. Negative 4 times, what's 1/2 to the minus 1? It's 2 to the 1. So it's 2 plus 2, negative 6. Negative 4, 1/2, 1 minus 1 plus 2. So negative 4, 1/2, what's 1 minus 1? 0 plus 2. And so what's this? Negative 4 plus 2, negative 2. I skipped it, right? Okay, it's the same as this, right? Plugging in 0. So we're going to get 0 comma negative 6. Okay, let's try to graph this. So the numbers are really way too big. You know what? Let me change the x-axis, the y-axis, the values for the y-axis so we can get one more point in there. So let's make this 4, 8, right? 12, 16, 20, 4, 8, 12, 16, 20. Okay, so where is my asymptote? Y equals 2, right there. Now, at negative 2, y is negative 30. That's still way too much. I don't need to graph that one. I could leave that one out. But at negative 1, y is negative 14. Huh? Say that again. At negative 1, we're at negative 14, right? I changed the volume of the wire. Oh, I'm going up by 2s. Well, look at what's going to happen now. So at 0, it's negative 6. At 1, it's negative 2. Okay? Okay, so now you're here, right? And you have no idea where this is going to go, right? You will know by the end of the chapter, but now you have no idea where it's going to go. So Lola had a wonderful idea. Let's add another point here. X equals 2, right? So what happens when we do that? Negative 4, 1/2, 2 minus 1 plus 2. So this is negative 4, 1/2 to the power of 1 plus 2. Negative 2 plus 2 will be 0. So that's going to be there. And now look at how this looks. It's going to follow the asymptote. It's got to. And go down here. Okay? Yes. I'll take a look. Okay. So now, let's talk about growth and... So what did we say this was? This was decay, right? So let's talk about growth and decay and stuff. Here. This is growth, and this is decay. All right. Does everybody agree that this purple one would be an example of growth, right? This would be like 2 to the x, right? It's very clear because, okay, like you've got no bacteria, and then all of a sudden you've got, trillions of bacteria. It grew so fast. Would this be an example of decay? Like this? So this would be like 1 over 2 to the x. That's decay because, look, you've got all this bacteria, and all of a sudden they decay. Well, let's go back to what I was saying before. For growth, something is growing. It's moving away from 0, right? It's moving away from 0. suppose we're not talking about bacteria. Suppose we're talking about somebody's bank account. Okay? What does it mean for you to be in the red? When you owe money, right? So, like, what will it show? It will show your balance of not $1,000, but negative $1,000. What if you now happen to fall further in debt? Now you don't owe. It's not going to show negative 1,000. It might show what? Negative 1,000,000, right? Or negative 1,000,000,000, like the country when countries go in debt, negative 1,000,000,000. So what happens when the debt is growing, right? So if this is 2 to the x, what if I were to graph negative 2 to the x? Well, now the country owed this much money, then they owed that much money, then they owed that much money, then they owed that much money. So do you see how the number is moving away from 0? So this is growth. Even though it's in the, like, it's down here in the negative y, it's still growth because your debt is growing. Now, what if things change? Your economy is doing better, right? And you're able to pay off some of your debt. So now, okay, you were this much in debt. Now you owe just $5 million or $1 billion. Now you owe $1 million. Now you owe, even less money. So look at what happened as time goes by, right? The amount you owe, your debt, is shrinking to 0. All right? So look, this is also decay. This is also decay. Both of these are decay. So what's the characteristic then? Decay, bacteria is moving down to 0. Your debt is getting closer to 0. So here, graphs always start from the left and they move to the right. So here, look, it's moving closer to 0. It's moving closer to 0. So the characteristic between growth and decay is that for decay, y value moves closer to 0. And for growth, y value moves away from 0. All right? So if this is decay, 1/2 to the x, this would be negative 1/2 to the x. All right? So that's how we know if it's growth or decay. So just know that for growth, it's got to move away from 0. For decay, it's got to move closer to 0. Yes? Uh-huh. Mm-hmm. The red one? Yes. You look left to right. Uh-huh. You're going down, but you're moving away from, so this is your debt. Just because the numbers are negative doesn't mean it's decay. This is your debt. Is your debt growing? Oh, it's growing, right? So you're moving into the negatives, but your debt is increasing from $1,000 to $1 million to $1 billion to $1 trillion. Okay? You're moving into larger and larger debt, larger and larger deficit. So growth and decay doesn't have to mean going up and going down. It has to mean moving away from 0 and moving closer to 0. That's how we know. I know it's a little bit counterintuitive. It takes a while to get used to, but that's the difference. Okay? All right.